Hi dear student, good morning. Today we are taking the topic properties of the vector product. In previous video you already see what is the meaning of the vector product and we see some simple properties of the vector. Now we see some more properties of the vector product. Also we have to solve some problem where we can use the vector product of the vectors. So dear student, let's we see. Properties are distributivity of vector product over addition. So suppose we are given three vector, if vector A, B, C, if vector A, B are any three vector and lambda be a scalar, then this follows the property that is known as distributive property. First one, vector A cross B plus C. If you find the distributive of vector product, our addition, this is our addition, this is cross product, our addition. So the property of the product, our additions. Clear? So what we see, if you want to solve this A cross B plus A cross C. So this will also followed by the vector product of the vectors. This is Q. Means either you can first add vector B and C, then find cross product with A, or individually you find the cross product of A with B and A with C, then result will be added. Both will be Q. Now if lambda scalar is given, so either lambda into vector A cross B you find, means first you find the cross product of the vector A and B, then with the lambda, or first you multiply lambda with the vector A, then cross product with B, or you can first multiply the lambda with the B and then you find the cross product. So order is not important for the scalar when we are using in the cross product, only scalar, but for the vector it is very important, direction will be given. Clear? So this is the third property. Now if vectors are given in component form, next we see that vector A equal to, which is given in component form, A1i plus A2j plus A3k, and vector B equal to B1i B2j plus B3k. This is vectors are given in component form and then their cross product we have to find. Then the cross product of vectors A cross B we want to find. So that is given by the determinant I, J, K, whose first row is given by the unit vector I, J, K, and second row of this given by the coefficient of I, J, K for the first vector, that is A1, A2, A3. Second row B1, B2, B3. So in this way one can find the cross product of the vector using the determinant. It is very easy or simple. Now how we can find this, or how we can say this is a Q, or its explanation we can find. Like see, if you find the direct cross product of the vector, as usual method, put the values A1i, A2j, A3k, cross B means component of B1i, B2j, B3k. Clear? So when you find the cross product, as usual this A1I multiply with this whole. So A1I cross B1I, B2J, B3K. Similarly, second A2 J multiply with this whole, cross with B1I, B2J, B3K. Then third point, A3K multiply cross with this A3K. This is the distributive property of the vector product or addition. B1I, B2J and B3K. Now we already know I cross I, that is 0, J cross J and K cross K. This we already used. Using this I, J, K. Clear? Using this circle, shall vector and cross product it will be 0, and I with J it gives you K. I cross J, K. J cross K, I. And K cross I, that is J. And if reverse order is there, then the sign will be negative. That we already see. So that all we have to use here. Clear? So see here, A1 I cross B1 cross means what we get? Scalar with a scalar and vector with vector. So I cross I, again you can say that will give you 0. Clear? See, so we can say I cross I. Similarly, A1 I cross with BJ. So scalar with a scalar and cross J. Plus I1 with B, A1 with B3, I with K. I cross K. Similarly for others you can find. So here say A2 with B1, J cross I plus A2 with B2, J cross J. Then A2 with B3, J cross K. And last will be A3 with B1, K cross I. Then A3 with B2, K cross J. And A3 with B3 and K cross K. Now put all these values. So I cross I, this will be 0, and J cross J, this will be 0, and K cross K, this will be 0. All three terms will be 0. Then you see I with J, this is I with J. So A1, B2, that will give K. I cross J, this is I cross J gives you direction K. Clear? Now see here A1, B3, I cross K. I cross K, direction is changed. So this will be minus J. So minus A1, B3, J plus J cross I. So direction again changed. J cross I. So that is minus K. So this is minus K. Then A2, B3, J cross K. That is I. J cross K gives you I. So that is plus A2, B3, I. And A3, B1, K cross I. So you can say here K cross J. That direction is changed. So that's why this is minus AJ, B1. So A3 B1 I, K cross J, then A3 B3 that is already 0. Clear? So in this way we get 1 2 3 4 5 terms are there. Out of 5 2 are cancelled, that is minus k and A3 B1 k. So finally what we get, that will be the value of the given 1 2 3 4 5. One term we have left, that we have to check which one is left. So this we are multiplying this by direct method. A cross B by pointwise we have to multiply, the result will be this. Now as we have seen in the chapter of the determinant matrices, if you are expanding this determinant along the first row, then what happen? I, then A2 B3 minus B2 A3. A2 B3 minus A3 B2 into I. Then we have minus sign here, expanding the minus j into A1 B3 into, so minus A3 B1. So A1 B3 minus A2 B3, and this is sign already minus j. Then K A1 B2 minus A2 B2. So in this way one can say the cross product can be easily, we can calculate by using the determinant. So that it will be easy form. So now we see some problem by using these properties or formula. So first one say, write down, find example 22nd, find A cross B. So find mode of A cross B if vector A equal to 2i plus j plus 3k and vector B equal to 3i plus 5j minus 2k. Clear? So you have to find the mode of cross product of the vector A and B. So A cross B can be easily calculated using this formula or using the determinant. So you can write here in solution, here vector A equal to 2i plus j plus 3k and vector B is equal to 3i plus 5j minus 2k. So A cross B is defined by the determinant whose first row is given by the unit vector I, j, k, and second and third is the coefficient of I, j, k. Coefficient of this I, j, k is 2, 1, 3. Coefficient of this 3, 5, minus 2. So we can easily find the product of these two vectors as using the rules of the determinant we have already seen, or you can also use the properties of the determinant to convert it into simplest form. So we can say I, if we are expanding along first row, so I, then 2 into 1 minus 3 into 5, then minus j, then 2 into minus 2, that is 4, and this 3 into 9 minus 9 plus k, then 2 into 5, 10 minus 3. So you simplify this, I 2 minus 15 minus j minus 13, then 7k, or minus 13i plus 13j plus 7k. So this is the cross product of the vector. Clear? Minus, here in the 2i, this minus 2, this is minus 2 we have left, here is minus 2. 1 into minus 2. This is minus 2. That's why this is 17. So minus 17i plus 13j plus 7k. This is the product. Now we want to find their modulus. We need mode. So already we know mode of a vector is given by root of the square, sum of the square of the coefficient of I, j, k. So minus 17 square, 13 square and 7 square. Clear? So add that gives you root 507. So in this way one can find the values. So next example we say find a unit vector which is perpendicular to each of the vector. This you have to find a vector which is perpendicular to the sum of the given vector and difference of the given vector. So first of all you have to find the sum and difference of these two vectors. So in solution you write here vector A equal to I plus j plus k and vector B equal to I plus 2j plus 3k. Now we want to find their sum and difference. So vector A plus B, that is I plus j plus k, add with a plus 2j plus 3k. So I plus I, 2i cap, j plus 2j, 3j cap, k plus 3k, 4k cap. Similarly, we want to find the difference of the given two vectors. So I plus j plus k minus I plus 2j plus 3k. So I minus I, that is 0. J minus 2, that is minus j, k minus 3, that is minus 2k. So we find the two vector a plus b and a minus b. So now a vector, as we have already seen in previous topic, a unit vector perpendicular to each of the vector is the product of the given, cross product of the given vector. So you may write a unit vector which is perpendicular to a unit vector which is perpendicular to both vector a plus b and vector a minus b is given by we are not writing unit because it is only first we find the vector then unit vector. A vector which is perpendicular to both vector a plus b and a minus b is given by their cross product. This vector a plus b cross a minus b. Now this is a plus b, we get a single vector, this suppose c. A minus b, that we get suppose d vector. So now we want to find the cross product of these two. So by using again determinant I, j, k and coefficient of vector a plus b, I, j, k 2, 3, 4. Then coefficient of this 0, minus 1, minus 2. And solve this one I using or solving expanding along the first row. So 3 into minus 2 is minus 6. Then minus minus plus 4. Then minus j 2 into minus 4 minus 4. Then 0 plus k 2 minus rho and 0. So finally solve is minus 2i plus 4j minus 2k. So we get a vector which is perpendicular to the given vector minus 2i plus 4j minus 2k. So this is the vector. Now we need a vector that should be unit. So by definition, a unit vector is given by, in general unit vector secant is given by vector divided by its magnitude. It means now we want to find the magnitude of this vector. Clear? So mod of C equal to root of coefficient of squares I, j, k. So minus 2 square 4, 4 square 16, minus 2 square 4. So we can say 24. So magnitude of this vector is 24, which can be written as 2 root 6. So use this formula. C cap equal to or unit vector equal to vector say minus 2i plus 4j minus 2k divided by 2 root 6, or individually you can write 2 root 6i 4 upon 2 root 6j 2 upon 2 root 6k, or you can cancel out. So finally what we get, minus I upon root 6 and this is 2 upon root 6j and then k upon root 6. So this is the required vector, which is the unit vector perpendicular to vector a plus b and vector a minus b. Next is so this is very important problem, how to find the unit vector. Next is find the area of the triangle. Next example, find the area of the triangle having the points when we are given the coordinate of the vertices of a triangle 1 1 1 b 1 2 3 and c 2 3 1 c 2 3 1 at its vertices So we want to find the area. So we know that to find the area for a vector, when two adjacent sides of the vector are given. So we want to find the side if coordinates are given. Clear? So we have vector AB. We find vector AB. AB means position of B minus position vector of A. Clear? Coordinate of B minus A. So 1 minus 1 0. 2 minus 1 that is 1. 3 minus 1 that is 2k cap. So this is the position vector AB. Similarly you find other vector adjacent AB to AC. So position vector of C minus position vector of A. So C minus A. So 2 minus 1. X coordinate separate with X, Y coordinate with Y. So we can say 2 minus 1 that is 1. Then 3 minus 1 2. 1 minus 1 that is 0. So we get the vector AB and base AC. So now we know that formula area of triangle is given by half of mode of cross product of the vector along the side. So here AB and AC. It means we want to find first the cross product of the vector AB and AC. Then we can find the so here AB cross AC. So use again repeated I j k. Coefficient of I first vector 0 1 k, second 1 2 0. So you extend along the first row I 1 into 0 0 minus 4 minus j 0 minus 2 into 1 k 0 minus 1. So we get minus 4i plus 2j minus k. So this is the cross product of the given two vector minus 4i plus 2j minus k. Now we need what? Modulus of this. So mode of AB cross AC is given by root of minus 4 square, 2 square and minus 1 square. Root of 4 square, that is 16, 4, 1, that is root of 21. So what is the area 1 by 2 of this? So 1 by 2 of this. So you can say the required area, the required area of the triangle is equal to 1 by 2 of root square unit. In this way one can find the area of the triangle if we are given the vertices. Similarly we want to find the area of a parallelogram. Area of the parallelogram whose adjacent sides are given by vectors. Here we are given in the form of vector by the vectors. Vector A equal to 3i plus j plus 4k and vector B equal to I minus j plus k. So we have to use the formula here. Same formula, only half will be removed. So you can write down. We know that area of a parallelogram. Area of a parallelogram is given by this formula. Mode of vector A cross B. Area of a parallelogram is given by formula mode of cross product of the vector along the adjacent sides. Clear? So we find the A cross B first. Again using the determinant. First row I j k. Second coefficient of I j of the first vector 3 1 4. Then next 1 minus 1 k. Coefficient is 1. 1 minus 1 1. Now we expand along first row. So I into 1 into 1 minus minus plus. So 1 plus 4. Then minus j. Then for j 3 into 1. That is 3 minus 4. Clear? For I we are taking 1 is minus minus plus 4. For j we are taking 3 minus 4. Now for k minus 3 and minus 1. So simplify 5i minus minus 1, that is plus j and minus 4k. So we get the vector 5i plus j minus 4k. Now we need what? Mode of this. So mode of vector A cross B. Root of coefficient of I square, j square and k square. So 25 plus 1 plus 16. Okay? So multiply this 26 plus 16 which is 42. So in this way we can say root of 42. So hence the area of the parallelogram will be root 42 square unit. So in this way, dear student, one can find the area of a parallelogram as well as area of a triangle by using the formula. So this is all about the today's class. to be continued with us for more videos. In next video we have to see miscellaneous exercise problem. So you must watch that one.